Hi, today we're looking at foundation level GCSE maths. We've got the Pearson Edexcel exam board and we've got the June 2022 paper 3. So this is one of the calculator papers. Question 1. Write 35% as a fraction. Well, don't need a calculator for this. 35% is simply 35 out of 100. Question 2. Work out 1/4 of 28. Well, of means times. So we can do this with the calculator. So we can just say 1/4. You can either use the fraction button or you can say 1 divided by 4. And then multiply that by 28 to give you 7. Or even simpler than that, you can say 28 divided by 4. Question 3. Write down 2 factors of 12. So the factors, as you know, are the numbers that go into the number with no remainder. So the easiest ones are the number 1 and the number itself, so 12. You could also have 2, 6, 3, 4, any 2 of those would be fine. Question 4. Simplify 2m times 3. So we just need to multiply the numbers together. So 2 times 3, which is 6. And then we've still got the m. Obviously you can use a calculator for 2 times 3, but I'm sure you don't need to do that. Question 5. So this one, I would use a calculator, because you can. So we want the square root of 1.69. Now with my calculator, yours is likely to do the same, but just check, they might do it differently. For example, if you've got a simple calculator, you'd probably need to type the 1.69 in and then the square root button. But on this one, I press the square root button and then 1.69 equals, and I get 1.3. Question 6. On the grid, draw a quadrilateral with no lines of symmetry and rotational symmetry of order 2. Okay, so quadrilateral, so that's a 4-sided shape. No lines of symmetry, so if we put a mirror on it, there's no reflection line. But we've got rotational symmetry of order 2. So that means that if you turn the shape upside down, it looks the same as the shape the normal way up. So I'm thinking, well, what shapes do we know that look like that? And one that springs to mind is a parallelogram. So let's actually, we'll have it over here. So we'll have 1, 2, 3, 4 across the top. What you can do is, if you're not sure, it's always good to do a sketch first and plan it out, and then so maybe do it on the side and then do it on the grid when you know that it's going to work. Okay, so if we put a mirror along here, we wouldn't get any lines of symmetry. It's not going to reflect perfectly. However, rotational symmetry, so if we turn the shape upside down, 180 degrees, it would perfectly fit this same shape here. So there we go. It doesn't have to be a parallelogram, but something along those lines is definitely going to be a good way to start. Okay, question 7. This is a 3-mark question. The table shows the total number of apples sold and the total number of oranges sold in a shop in each of 3 weeks. So in week 1, they sold 86 apples and 68 oranges. And same for week 2, week 3. In total for the 3 weeks, more apples than oranges were sold. How many more? So what we need is a total. Work out total number of apples, total number of oranges, and then we just work out the difference. Okay, so for that first row, we're going to have 86 plus 75 plus 92. So we've got 253, that's our total apples. And then we're going to do the same for the oranges now. So we want 68 plus 80 plus 76. Got 224. So we want to know how many more apples than oranges, so we're just going to subtract one from the other. So 253 minus 224, we've got 29. And we can put that on here for our 3 marks. Question 8. Here are the first 5 terms of a number sequence. Write down the next 2 terms of this sequence. So a good starting point is to look at the difference between them. So if I want to know the difference between 3 and 8, I could just count. So 4, 5, 6, 7, 8. That means I'm adding on 5. Or I could take 8 minus 3 is 5. Let's check the difference between these two. 13 minus 8. That's also 5. We're adding on 5. And check here. 18 minus 13 is 5. So what about if we add 5 onto 18? We get 23. So if we want the next 2 terms, well, that was add 5 as well. So we can add 5 to 23 to get 28. And then we'll do it again to get 33. And then put those on the answer line. Okay, we've got part B here. Jim says that 50 is a term in this sequence. Jim is wrong. Explain why. You can try and explain it in words, but actually what I would do is I would just write the next terms. So we can say 33, then the next one. So if we add 5 to that, we get 38. Add 5 again, 43. Let's keep going, 48, until we get up to 50. Or go beyond it. So we can, to be honest, that's probably enough. Okay. Question 9. We've got 2 parts here. Each part is worth 1 mark. The diagram shows a solid triangular prism. Write down the number of faces of the prism. Okay, so we've got, think of it as like a tent. We've got one side on the left. We've got this other side on the right. We've got the front triangle, the back triangle, and then we've got the base. So that's 5 faces in total. Or you can think you've got 3 sides of the triangle. So left, right, bottom, and then you've got the 2 ends. Both ways you should come up with 5. Write down the number of edges of the prism. Okay, well we've got 1, 2, 3 on this triangle. We've got another 1, 2, 3 on that triangle, so 3 plus 3. Then we've got the ones that join them together, so 1, 2, 3. So 3 plus 3 plus 3, that's a total of 9 edges. Or you can just go round and number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Question 10. Here is a list of 8 numbers. 2, 2, 3, 5, 6, 6, 8, 9. Kim picks at random one of these numbers. On the probability scale below, mark with a cross the probability that Kim picks a number 7. Well, we haven't got any 7s, so it's going to be a probability of 0. Part B. On the probability scale below, mark with a cross the probability that Kim picks a number greater than 5. Right, so we've got 1, 2, well they've told us there's 8 numbers, so it's going to be out of 8. We want a number greater than 5. Smaller, 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 that's the same. So greater would be 1, 2, 3, 4. So 4 out of 8, which actually if we do 4 divided by 8, we'll see it's 0.5. You can press the SD button. Oh yeah, it's a half. So we can put our cross there. And for part C, find the probability that Kim picks an even number. Well, again, we know it's going to be out of 8, because that's how many numbers we've got. How many of these are even? 1, 2, 3, 4, 5. So it's simply going to be 5/8. Question 11. Sunita wants to make 35 picture frames. She needs 4 nails for each frame. Sunita has 3 boxes of nails. There are 48 nails in each box. Has Sunita got enough nails to make all 35 frames? Show how you get your answer. And this is worth 3 marks. So what we're going to do here is we're going to split this up into 2 parts. We're going to look at this bit to see how many nails she needs. And then use this information to see how many nails she's got. And then we can compare for that 3rd mark. So we're going to need 35 times 4. It's got 4 nails for each picture frame. So that's 140 that we're going to need. She's got 3 boxes with 48 in each. So that's 3 times 48. Which is 144. So this is what she needs. This is what she's got. Has Sunita got enough nails? Yes, because 144 is greater than 140. They give you a lot of working out space, but really you don't need to do an awful lot. It might help if you want to draw a picture frame, if you can't think where to start. You know, you can draw a picture frame, something like this. And think about, oh, well, where would my nails go? 1, 2, 3, 4. And that will help some people to visualise it. But that's just optional if you want to. Question 12. Write 60 metres as a fraction of 1,000 metres. Give your answer in its simplest form. So 60 over 1,000, we're going to simplify it. So we can cancel a 0 there and there. Now, because we can use a calculator in this, what we can do is, I was going to say cheat. It's not cheating, it's using the equipment you've got. So you can just do 60 divided by 1,000 equals. Now, first of all, I've got mine set to default to decimals. Yours might show you a fraction straight away. If not, you can press the SD button and it simplifies it for us. When it shows it as a fraction, it always shows it in its simplest form anyway. So there we go. Let's say if you wanted to do it manually, then I'd say we've got 6 over 100 now. They're both even numbers, so I'd divide them both by 2. 6 divided by 2 is 3, 100 divided by 2 is 50. So you'd still get there. This is just a little bit quicker using the calculator. Question 13. The accurately drawn map shows the positions of 3 points, A, B and C, in a field. Okay, and we've got scale here. 1 centimetre represents 150 metres. So 1 centimetre on here is 150 metres in real life. They're also showing us where north is. So what I'm going to do is just remind myself with the compass directions. So north, south. So never eat shredded wheat. Okay. Parveen walks in a straight line from A to B. So let's draw a straight line. She then walks in a straight line from B to C. B to C. So that's Parveen. Susan walks in a straight line from A to C. Right. Oh, we can't see that bit. So let's bring it up. Yeah, Susan walks a straight line from A to C. So this is Susan. And these two are Parveen. Parveen walks more metres than Susan. How many more? Okay, well, let's measure it then. So, get my ruler here. We're going to do Parveen first. Well, for me, that looks like 5 centimetres. And then up here, I'll measure it this way just because my video is making that be in the way. So that's 4 centimetres. So Parveen is 5 plus 4, so that's 9 centimetres. Now, if 1 centimetre is 150 metres, we need to multiply that by 150 to get our distance in metres. So 9 times 150. Actually, I shouldn't put equals, really, because what we're saying is we're converting it. So we're saying that that's 1,300, or it represents 1,350 metres. So for Susan, we can do something similar. We're going to measure this distance here. And we get 7 centimetres. So 7 centimetres, well, we want to multiply that by 150 to get the distance in metres. So we're using the scale. So remember, 1 centimetre is 150, so 7 centimetres would be 7 times 150, which is 1,050. So we want the difference between them, that's metres, so we want 1,350 minus 1,050, .300 metres. If you want, you could work it all out in centimetres first. So we could have done 9 centimetres minus 7 centimetres is 2 centimetres, and then we could do 2 times 150. You still come up with 300 metres. So the order doesn't matter. So that was 3 marks for that part there. Let's write it on. And then for part B, find by measurement the bearing of A from C. Okay, so by measurement, that means we're going to have to use our protractor. A from C. So from C means we're starting here. So we start at north and we go all the way around until we get to the line pointing to A. So this is the angle that we want to work out. Okay, I'm going to call it theta. Doesn't matter, I'm just giving it a symbol. Now, rather than trying to measure that angle, what I'm going to do is measure this one in between. So, put this on here, line it up. Let's see. This protractor isn't the best. The ones that have lines that go all the way through them are a bit better. But with this one, if that carried on up, I would say that would be about here. That would probably be about 72 degrees, I think. So this angle, 72 degrees. I know that the total number of degrees in a circle are 360. So if I do 360 degrees minus 72 degrees, I'm going to get 288 degrees. And we can put that down here. Usually they would let you be within 1 or 2 degrees. They just want to see that you can use the protractor accurately. Now normally I would try and see if it goes to a nice sort of round measurement, but with this one it just didn't look like it was going to. So if you can, go close, but if you can't, if it's clearly, as I say, with this one, I don't know, maybe 70. No, it's not. It's definitely not on 70. So you would need to go beyond it. 71 would probably be all right, or 72. Just remember to take that away from the 360 because it's this angle that we want around the outside. Question 14. Here is the shoe size of each of 12 boys in a class. 4, 5, 6, it looks like they've put them in order for us. Find the median. Well, the median is going to be the middle number. We need to sort them, but they've been sorted, so we can take them as they are. So we cross off the smallest and largest. Keep going in pairs. Keep going. Now, because we've got an even number, it means we're going to end up with 2 in the middle. Normally, we'd add them together and divide by 2, but because they're the same, it's just going to be 7. Work out the range. Well, the range is the biggest minus the smallest, or the difference between the biggest and smallest. So 9 minus 4, which is 5. Now, for the shoe sizes of each of 12 girls in the class, the median size is 6 and the range is 3. Compare the distribution of the shoe sizes of the boys with the distribution of the shoe sizes of the girls. So we're really just comparing our numbers. So what we can say is, so we'll do one on the median, I think. So the girls have, we're comparing 6 with 7. So the girls have a smaller average shoe size. And we can say median of 6 versus median of 7 for boys. That's our first bit. And then we want to say something about the range. So girls have got a range of 3, boys a range of 4. So the shoe sizes. When we're talking about ranges, we like to talk about consistency. So the shoe sizes are more consistent. In other words, they're closer together for boys than the girls. And it's always good to quote the figures, so we can say range of 3 versus range of 5 for boys. We've got 2 marks, so it's 1 mark is talking about the median and 1's talking about the range. Oh, I missed a question down here. Right, we've got question 15. Nearly got away with that one. Work out 2.75 times 14.6, all divided by 10 minus 1.97. Right, now because we've got the division here, it means that essentially it's like we're putting brackets around these 2 bits. We need to work out the top separately and the bottom separately. So you could do it all in your calculator in one go, and if you did that, you'd need to use brackets. So you could do it like this: 2.75 times 14.6, close your brackets, then divide, open the brackets, 10 minus 1.97, close the brackets, and we get an answer of 5. Or what I like to do, especially in an exam where it's easy to make a mistake, is to do the bits separately. So just do the top, 2.75 times 14.6, we get 40.15, and the bottom, 10, or the denominator, minus 1.97, we get 8.03. Then we can do that, 40.15 divided by 8.03, and we get 5. Doesn't matter which way you do it, I just think this feels like you've got more control. If you just type this all in and you've made a mistake, it's very hard to spot that you've made a mistake. You're just completely trusting your calculator. Whereas on here, I can see, well, I've got about 3 times about 14, so that's going to be something around 40. And 10 minus about 2 is going to give me 8. 40 divided by 8 should be about 5. So you can do some sort of spot checks as you're going as well. Question 16. On the centimetre grid, draw an isosceles triangle with an area of 12 centimetres squared. Right, so, and this is for 2 marks. Isosceles means that we've got 2 sides and 2 angles of the triangle the same. So, for example, it might be something like that would be an isosceles. You could also do like one that's a bit more like that. So it doesn't matter too much what it looks like, but we want the area. Now the area of a triangle is half times the base times the height. That's a B for base. We know that all of this needs to equal 12. Well, if it's half of base times height is 12, then this is the same as saying, therefore, base times height is going to have to be double that. 2 times 12, which is 24. Because if we're going to half it, we could get 12, so it needs to be 24. So basically, we've got to draw a triangle, which has got, when you multiply the base times the height, you get 24, and it's got 2 sides the same length. So I'll pick that as my centre point. Now, what numbers can we multiply together to get 24? Well, I know 4 goes into 24. And it goes in 6 times. I could use 2 times 12, but I'm going to do 4 times 6 is 24. So if I go down 1, 2, 3, 4, 5, 6, I'm going to have a height of 6. That means I want a base of 4. So I can go 2 on that side and 2 on that side. So let's draw this. So we've got 4 across the bottom. This height is 6. Remember, it's the vertical height of the triangle that's important, not the length of the sides. So there we got it. So there's a few different combinations. We could have had a base of 6 and a height of 4, or others that you could do as well. And we don't need to show it. We've got the numbers on there. Question 17. Let's see if I can fit the whole question on. Yeah. Expand 3 brackets 4 minus 2x. So when we've got a number next to brackets, there's an invisible times in there. So we have to do 3 times the 4 and 3 times the minus 2x. So 3 times 4 is 12. And then 3 times minus 2x, well, 3 times minus 2 is minus 6. And we just keep the x on. Part B, solve 3y divided by 4 equals 12. So we need to rearrange it really. Let's move this 4 over to this side. So we're dividing by 4. So if we move it to the other side, we're going to multiply by 4. So that means we've still got the 3y. The 4's gone. We've now got 12 times 4, which is 48. If 3y is 48, then 1y is going to be 48 divided by 3. Again, this is multiply at the moment. We move it to the other side, it becomes divide. So 48 divided by 3 gives us 16. Part C, factorise 4p plus 6. So we're looking at numbers or letters that go into both parts of this. We've only got p on in this bit, so it's not going to be p. What about the numbers? Well, they're both even numbers, so 2 goes into both of them. So we can take the 2 outside the brackets, because really factorise means put some brackets in. So 2 times what gives us 4? 2 times 2 gives us 4. but we want 4p, so it's going to have to be 2p. So when we multiply those together, 2 times 2p gives us 4p. And to get plus 6, we need 2 times something, and 2 times 3 gives us 6. So 2 times 2p gives us 4p, 2 times 3 gives us 6. Question 18. Write 2,530 correct to 2 significant figures. So that means we essentially want to round it, but to the first 2. So that means we want thousands and hundreds, or in other words, round to the nearest 100. So 2,530, we want it to these 2, so we look at the next digit and we say, well, 3 is less than 5, so we're just going to keep it as 2500. So another way of thinking of it, 2 significant figures. Start from the left and see what the second place is. It's in the hundreds, so it just means round to the nearest 100. And you could also then think, well, what hundreds is it between? Well, it's going to be between 2,500 and 2,600. Halfway would be 2,550. 2,530 is going to be in this side. So we round down. It's only worth 1 mark. You choose what method you prefer and go with that. Write 0.0874 correct to 1 significant figure. So similar to before, we sort of start from the left and we keep going until we find the first whole number. So not a 0. We want the first significant figure, so it's the 8. So again, we look at the next digit, and if it's 5 or more, we're going to have to round up. It's more than 5, so we're going to have to increase the 8 to a 9. Question 19. This is worth 4 marks, this one. There are 400 counters in a box. The counters are red, or yellow, or green. 3/8 of the counters are red. 82 of the counters are yellow. What percentage of the counters are green? So before we work out what percentage are green, we need to work out how many are green. So we can do that by finding out how many are red, how many are yellow, take them away from 400, and then we'll be left with the number of green ones. So 3/8 of the counters are red. So we want 3/8 times 400. 3 divided by 8 times 400 is 150. You might prefer to think of it as doing 400 divided by 8, so you find out what 1/8 is and then multiply it by 3. It's up to you which way you want to do it. So we've got 50 here, we've got 82 are yellow, so 150 plus 82 gives us 232. So that's red and yellow. So if we take them away from 400, we get 168, which are green. If we want to turn that into a percentage, well, it's 168 out of 400 and multiply by 100 to get our percentage. So 168 divided by 400 times 100, 42% for 4 marks. Question 20. In the diagram, PQR is an isosceles triangle with PQ equals PR. So PQ and PR. So this is our isosceles triangle. That side's the same as that side. So that means that that angle would be the same as that angle. APR, so this line, and CQD down here are parallel lines. And they've shown us that by putting the arrows on. Angle APB. APB is 56 degrees. And they want us to work out the size of angle CQR. CQR. So that's this sort of this full angle here. Okay, so I was just pointing out that little one. They want this full one here. And give a reason for each stage of your working. Now this is worth 5 marks. Okay, so where to start? Well, what I'm going to go with is, I think if we can find out what the angles are in this triangle, that might help us. So it's good to think, if you can't see how to get to the answer straight away, think, well, what do I know? What can I work out? So opposite angles, when you've got two lines crossing, are equal. So this is going to be the same as that, 56 degrees. And this is because opposite angles are equal. That's enough of an explanation. Okay, so we know that angle. Now, you can also see that this angle up here is the same as this angle down here. Now, this is what we would call a Z angle. So we can say this is 56 degrees and we can put Z angles. That's enough just to show what rule we're using. So we know this bit here. If we can work out this smaller angle, we can then add them together. Now, I also know that total angles in a triangle add up to 180 degrees. And I also know that these two angles are the same because it's an isosceles triangle. So if I take off the 56, that's going to give me the total of these two angles. So 180 minus 56 gives 124 degrees. And because it's the two angles, we want just one of them. So we want 124 divided by 2, which gives us 62 degrees. So this, let's do it up here. So this is 62 degrees. This one over here is also 62 degrees, but we're interested in this. So we want the 56 plus the 62, which gives us 118 degrees. And that's for 5 marks. So you might not see how to do it straight away. It's absolutely fine. I say use what you know. Start off, even if you don't get all the way there, you might get 1 or 2 marks. So the opposite angles, the Z angles, angles in a triangle, all those things are going to be useful to pick up marks. Question 21. Work out the lowest common multiple of 24 and 56. Right, lowest common multiple. So that means numbers, or the smallest number, which is both in the 24 times table and in the 56 times table. So we could do that. We could kind of write them out and compare them. Is it worth doing that? Yeah, let's try. So if we start with 56. Well, first of all, just 24 go into 56. Not without remainder. So, okay, so what about 2 56s? 2 times 56 is 112. Can we divide 24 into that? No, we've still got remainder there. So let's go our next 56. So 56 times 3, 168. Does 24 go into 168? Yes, it does. So that's 7 24s. So the lowest common multiple is 168. If you want, you can do it with prime factorisation. So you can take 24 and break that up into 2 times 12, and 12 we can do 2 times 6, and then 2 times 3, and do it that way. But actually, when you've got numbers like this, do the times table of the bigger number and just keep dividing the other one into it until it goes a whole number of times. It's going to depend on your numbers which is the best way to do it. If you do it enough times in practice, you'll get a feel for what's going to be the quickest way. Sometimes they might ask you to use prime factorisation, so you'd have to do it the other way. But on here they haven't. They've just said work out the lowest common multiple. So you can do it whichever way you want. Okay, question 22. Here is a right-angled triangle. We've got 3 other sides. Here's our right angle. Work out the value of x. So this is a Pythagoras question. You should remember from Pythagoras that a squared plus b squared equals c squared, where c squared is the hypotenuse. So in other words, that's saying 4 squared plus x squared equals 8.5 squared. So let's work those out. So 4 squared is 4 times 4. I could use the square button, but I don't need to. 16 plus x squared equals 8.5. Now I'll do squared. 72.25. We want to find what x is. So let's move the 16 to this side, so it becomes a minus 16. So we get x squared is equal to 72.25 minus 16, which is 56.25. That's x squared. If we want just x, well, then we need to take the square root of 56.25. Square root answer, or I could type 56.25 in, and we get 7.5. Don't forget to put units. Question 23. T equals 4m squared minus 11. Part A. Work out the value of t when m equals minus 3. So we're going to have 4 next to the m means times m. The m squared is minus 3. And because it's squared, it means it's the minus 3 squared. So minus 3 times minus 3. And then minus 11. So you could put that in your calculator as it is. So 4 times. Now, because we got the minus 3 that's squared, we do need to put the brackets around it and then square it, then minus 11. Now, if we do that, you see that we get an answer of 25. Now, I just want to show you what happens if we didn't do it with the brackets. If we just did 4 times, I'm not sure if it would work actually, minus 3 squared minus 11. Yeah, because what it's doing is it's saying minus 3 squared. So you've got minus 3 squared or minus 3 squared. So in one of them the minuses cancel, in the other ones they don't. So you've got to make sure that you do it this way. Or if you want to think of it how you do it manually, you would have 4 times minus 3 squared is minus 3 times minus 3. 3 times 3 is 9. The minuses cancel, so it's actually a positive 9. So you're saying 4 times 9, doing this first, and then minus 11, which is the same as 4 times 9, which is 36. Then subtract the 11 to get 25. Okay, so you could be caught out depending on how you do it. Just make sure it's the whole minus 3 that's squared, not just the number 3. And for part B, make P the subject of the formula D equals 3p plus 4. Well, because we want p the subject, I'm going to turn this the other way around. I'm going to start off with my p's on the right, on the left. So 3p plus 4 equals D. Now I want to get rid of the 4, so move it over. So to get rid of it, move it the other side, it becomes a minus 4. So we get 3p equals D minus 4. Now we want to keep the p, we want to get rid of the 3. So divide by the 3. So it's literally going to be p equals D minus 4, all divided by 3. Question 24. This is a 5-mark question. Rick, Selma and Tony are playing a game with counters. Rick has some counters. Selma has twice as many counters as Rick. Tony has 6 counters, less than Selma. In total, they have 54 counters. The number of counters Rick has to the number of counters Tony has equals 1 to p. Work out the value of p. Right, so what we can do is start to maybe we can work out how many counters they each have. Let's try. So we'll draw some expressions for these. So Rick has some counters. Okay, let's say that he's got R counters. Selma has twice as many as Rick. Okay, so I can say Selma equals 2R, 2 Ricks. Tony has 6 less than Selma. So Tony is Selma minus 6. Okay, so if we use that, we can think, well, and we know in total they have 54 counters. So we can say, well, that means that Rick plus Selma plus Tony equals 54. Now, we want to try and get these all in terms of the same letter. So, keep Rick as it is. Selma is 2R. So instead of S, we can put 2 lots of Rick. And instead of Tony, well, Tony equals S minus 6. But we know S is 2R, so we can say, well, substitute the 2R for the S. We can say that's 2R minus 6. So instead of T, put plus 2R minus 6. That now equals 54. So we've just written everything in terms of Rick. So we've got 1R plus 2R, that's 3R, plus another 2R, that's 5R. So let's move this down here. So we've got 5R minus 6 equals 54. So we can solve this to find out how many R is worth. So move the 6 over, so that becomes a plus 6. So we get 5R equals 54 plus 6, which is 60. And then 1R, we're going to move that, that's a times, so do the opposite, it's going to become a divide. So we get that R equals, so 60 divided by 5 is 12. Okay, so we know Rick's got 12. S is 2R, so S equals 2 times 12. 24. And Tony equals, well, S minus 6. So it's going to be 24 minus 6 is 18. Okay, so Rick's got 12, Selma's got 24, Tony's got 18. Now, they said the number of counters Rick has So we want Rick to Tony, and they've got it as 1 to P. Actually, I'm going to draw this as a little table, I think. Yeah, we can just do it like this. So they want it written as 1 to P, and we've got to work out what this P is. Well, at the moment, we know that when R is 12, Tony is 18. So if we want to make this 1, well, to get from 12 to 1, to go that way, well, we just need to divide it by itself, divide it by 12. So to find out what P is, we have to do the same thing. We also need to divide that by 12. So if we do 18 divided by 12, we get 1.5. So it's saying that Tony has got 1.5 times what Rick's got, which makes sense here. Okay, because if we do 12 times 1.5, we get 18. 5 marks. Now, it might be a little bit unusual or unsettling, the fact that you've got a P that's 1.5. Normally with ratios we don't tend to have decimals, but we can do. In this case it's worked out that way. But I think the best way to do it, work out how many actual counters they've got each, and then our ratio table ends up being quite a simple one. We only need Rick and Tony. We don't need a total or Selma or anything else. Question 25. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of rolls of wallpaper from each of 2 shops. Okay, so Chic Decor, 3 rolls for £36. Style Papers, pack of 5 rolls, normal price £70, 12% off the normal price. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chic Decor or from Style Papers? You must show how you get your answer, and this is worth 4 marks. Right, so if 3 rolls are £36, we want 15 rolls. So how many 3s go into that? So 15 divided by 3. Again, hopefully you don't need your calculator for all of these, but it's always good to check. Is 5. So we want 5 lots of 36. So that's going to be £180. Now, we've got 2 bits going on here. We've got the 12% off, but we've also got to work out how many packs we're going to buy. You can do it either order. I'm going to do the packs first, I think. So if we've got a pack of 5 rolls, well, I want 15 divided by 5 so that I know how many packs I need. 15 divided by 5 is 3. So I want 70 times 3, which is £210. But we've got 12% off the normal price. Okay, you could take it off the £70 before, or take it off here. I'm going to take it off here. So the way I'm going to take it off is I'm going to say 12%, so 12 out of 100 times 210 is £25.20. And then I'm going to take it away, so I'm going to say 210 minus 25.20. I've done it backwards. Let's do 210 minus answer, so we get 184.8. Because it's money, it needs to be 2 decimal places. £184.80. So should Joe buy from Chic Decor or Style Papers? Well, Chic Decor. And we can show that because £180 is less than £184.80. 4 marks. Question 26. The table gives information about the lengths in centimetres of some pieces of string. Okay, so there's 15 pieces of string that are between 0 and 10 centimetres, 20 pieces that are between 10 and 20, 50 that are between 20 and 30 centimetres, and so on. Amos draws a frequency polygon for the information in the table. Let's have a look at that frequency polygon. Lengths of pieces of string. So we've got the length across here, frequency up the side. Write down 2 mistakes that Amos has made. Okay, so with a frequency polygon, because we've got ranges here, what we would do really is we'd use the midpoint. So halfway between 0 and 10 is going to be 5. Halfway between 10 and 20 is 15. What you can do is add the 2 together and divide by 2, or you can just sort of count and work out halfway between 20 and 30 it's going to be 25. Halfway between 30 and 40 is going to be 35. And halfway between 40 and 50 is going to be 45. So that means he should have picked 5, 15, 25, 35 and 45 for his points. But no, he hasn't. He's used 50. So one mistake, we can say the last point should be at 45 centimetres, not 50 centimetres. Okay, that's one mistake. Okay, anything else? If we look at the frequency, we start in 0, go up 2 squares to 10, up 2 squares to 20, 2 squares to 30, 2 squares to 50. Where's 40? So that's going to be the second mistake. The frequency misses out 40. Okay. There might be other mistakes. Those are certainly the 2 that stood out for me. Question 27. Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Give your answer in miles per hour. So here it might be useful to think of this little triangle which connects distance, speed and time, and it's that distance is speed times time. Okay. Now, what we want to do to work out Amy's average speed is we need, for speed, we're going to need the distance and divide it by the time. Now we know the time is 45 minutes, so we need to work out the distance. Now we're told that she runs the same total distance that Jessica runs, so we've got to work out how far does Jessica run. That's the first thing we're working out, and it's for 4 marks, this question. So she runs for 15 minutes at an average speed of 6 miles per hour. Well, 15 out of 60, because there's 60 minutes in an hour, is 0.25. Or think of it as a quarter. So she's running for a quarter of an hour at 6 miles an hour. So if we make that multiply, if we multiply that by 6, it'll tell us how far she's actually going to run. So if it was a full hour, she'd run 6 miles, but because she's only running for a quarter of an hour, it's going to be a quarter times 6, which is 1.5 miles. She then runs for 40 minutes at an average speed of 9 miles per hour. So now we can say, well, it's 40 out of 60 at 9 miles an hour. So 9 would be if we're running for a full hour, but we got 40/60ths of that. So 40 divided by 60 times 9 gives us 6 miles. Or if you think what we're doing here really, to work out the distance, we're doing the speed times time. So this is our speed. But the thing to note, these are our time, but it's time in hours. That's why we're having to divide by 60, because we're doing miles per hour. We're not doing miles per minute. These are minutes, that's why we're having to divide them by 60 to get them into hours. So, how far does Jessica run? It's going to be 1.5 plus 6 miles. 7.5 miles. So if we want the speed for Amy, we've got the speed is distance divided by time, so the distance is 7.5 miles. The time, well, it's 45 minutes. Remember, that's 45 out of 60. Now, let's work that out. If we do 45 divided by 60, that's equal to 0.75. So we've got 7.5 divided by 0.75, which gives us 10 miles per hour. Okay. And we can write that down here, and this is worth our 4 marks. Question 28. The diagram shows rectangle STUV. Okay, so STUV, TQU, straight line, and SRV is a straight line. All measurements are in centimetres. And we're told the area of trapezium QUVR, so QUVR, is A centimetre squared. Okay, so this is all A centimetre squared. They've asked us to show that A equals 2x squared plus 20x. Right, that sounds quite cryptic at the moment, but what we can do is we can think, well, how would we normally work out the area of a trapezium? Well, the area of a trapezium is half of A plus B times the height, where A and B are the parallel sides, so that'd be A and that would be B. Okay, so let's see if we can do something with this. Well, B, we've got that this is 5 centimetres, so that's fine. How can we work out what A is? Well, it's going to be all of this, so A is going to be 3x plus 5, the full width, but minus the 2x, this little bit. So 3x minus 2x is going to be x, and we've still got the plus 5. So that means that this is equal to a half, and in the brackets we've now got 5 plus x plus 5, and then all of that is times the height, which is 4x. Okay, so we'll just do this step by step. So we've got the half and the 4 on the outside of the brackets. Well, half of 4 is 2. So I'm going to do the half times 4 is 2. We've still got the x. We've got 2x outside. Inside the brackets, we've got 5 plus another 5. And we've got an x. We've got an x plus 10. So if we multiply out the brackets, we've got 2x times x, which is 2x squared, and 2x times 10, well, 2 times 10 is 20, times x is just x. So this is equal to this. Done. Okay, so that was worth 3 marks. It looks scary. Let's say what you're trying to do is you need to know your formula, and then substitute your values in with a little bit of algebraic manipulation. Question 29. Change 30 metres per second to kilometres per hour. Right, so I'll do it a bit at a time. So we've got metres per second. Let's work out metres per hour. Okay, so if it was per hour, we would have 30 metres in the first second. We've got 60 seconds, so that would be 30 metres in a minute. And 60 minutes in an hour. So we would have this amount of metres in 1 hour. So 30 times 60 times 60 be 108,000. Still metres, but that's per hour. Okay, because we're trying to get from metres a second to kilometres per hour. So what we've done first is we've turned the we've turned the seconds into hours first, and then we're going to do the metres into kilometres afterwards. So we've got 108,000 metres per hour. We want to go to kilometres. Well, I know that there's 1,000 metres in 1 kilometre, so we're going to need to divide that by 1,000, which gives us 108. We've now turned that into kilometres, and we're in hours. And finally, for this paper, we've got question 30. The value of Michelle's car has decreased by 15%. The car now has a value of £13,600. Work out the value of Michelle's car before the decrease. So if it's decreased by 15%, it would have started off at 100%. If it decreases by 15, you're left with 85%. So this price of 13,600 represents 85%. So we can't work out 15% of this and add it on, because it's not 15% of this. It's 15% of the original number that we don't know. So what we can do instead is say, well, we can use this to work out what 1% would be. So we can do 13,600 divided by 85. So that's £160 represents 1%. So if we want 100%, we multiply that by 100, which gives us £16,000. That's the end of the paper. Hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on to find out when I add more videos, and I look forward to seeing you again soon. Thank you.